name is Swarnalatha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on the Gaussian and Poisson random process. So, telephone calls are initiated through an exchange at an average rate of 75 per minute and are described by a Poisson random process. Find the probability that more than 3 calls are initiated in any 5-second period. So, what type of random process are given is a Poisson random process. So, what is a Poisson random process? So, already in the previous lecture, we have seen the Poisson random variable as well as a Poisson random process. So, what is a Poisson random variable? A Poisson random variable is an approximation to the binomial random variable which are applicable only for the Bernoulli experiment. The Bernoulli experiments is nothing but only the experiments having only 2 outcomes. For example, if you flip a coin, you get only 2 outcomes, nothing but either getting a head or coin. If you write the exam, you will get only 2 outcomes, either passing the exam or failing the exam. It means the binomial random variable as well as the Poisson random variables are applied to the Bernoulli experiments. And what is the difference between this binomial random variable and Poisson random variable? The binomial random variable and the Poisson random variable difference is if the number of trials are very large and the probability of success is very less, then you can go for Poisson random variable instead of the binomial random variable. And what is a Poisson random process now? So, for this Poisson random variable, if you include a time function, then that Poisson random variable is called as what? Poisson random process. So, for this Poisson random variable, if you include a time function, then it is called as what? Poisson random process. So, what they are given that, and moreover, the Poisson random process is used for, this is one type of application which are applied for what? Bernoulli experiments. And second type of application of the Poisson random variable is for counting applications. The Poisson random variable and the Poisson random variables process is used for what? Counting applications. What are counting applications? For example, if you want count the number of telephone calls made per 1 minute, or else if you want count the number of equipment, the number of items having in a box. So like that, or else you can count the number of persons entering the supermarket in 1 hour. Like that, for counting applications, and you want to calculate the probability for counting the number of persons enter the supermarket for in 5 minutes, how many persons are entering the supermarket, or the number of cars are availing at the petrol bunk or at the signal. So like that, for counting applications, you can go for what? Poisson random variable in order to find out the probability. So the question here is, the telephone calls are initiated through an exchange at the rate of 75 per minute. What does it mean? 75 per minute, nothing but what? Per 1 hour, in 1 minute, 75 telephone calls are coming. How many telephone calls are coming? For 1 minute, how many telephone calls? 75 telephone calls. Nothing but what is average here rate? Nothing but lambda equals to 75 per minute. Since the time period they are given in terms of second, either this you can convert into minutes or else you can convert this minutes into second. So, per minute 75, nothing but per second, how many will be there? 75 by 60 per second. So, per 1 minute, nothing but 75, then per 1 second, 75 by 60. Then, what is time duration of interest? They are given t equals to 5 seconds. So, what is the probability to calculate? Find the probability that more than 3 calls are initiated in any 5-second period. What is the time period t here? 5 seconds. Then, what is lambda into t? What is lambda here? Average rate. So, 75 by 60 into 5. Nothing but what? 75 by 12. Now, you have to calculate the probability that, what is the probability that the number of telephone calls should be what? Greater than 3, more than 3 in how much duration of time? In 5 seconds of time. Nothing but p of x of t is greater than 3. Nothing but what? 1 minus p of x of t is less than or equal to 3. So, then nothing but 1 minus. So, what is less than or equals to 3? Nothing but So it is nothing but equal to 3, nothing but 3, 2 x of t equals to 2, 1 and 0. We can't write down the negative values. So whenever you have kept in the probability, you can't write down the negative. Nothing but no cause will be there, or only one call, or two call, or 3 calls will be second. 3 calls will be made in 5 seconds. Therefore, you have written down p of x of t equals to 3, p of x of t equals to 2, p of x of t equals to 1, and p of x of t equals 0. Then what is the probability that p of x of t is equals to k? Nothing but e power minus lambda t by lambda t power k by k factor. Nothing but probability that the event has been occurred exactly k times. Exactly 3 times, 2 times, 1 time and no time. Therefore, 1 minus. Here, what is e power minus lambda t value? What is lambda t equals to 75 by 12 here. So, therefore, you can write this as what? E power minus lambda into t. So, it is constant for all the values of k. Therefore, I am writing e power minus lambda, nothing but e power minus 75 by 12 as constant, and remaining if k equals to 3, then what can happen here? So what is lambda into t value here? 75 by 12 into what is k value here? 3 by 3 factorial plus here lambda t nothing but 75 by 12 and k value nothing but 2 by 2 factorial plus and so on. So if you simplify that, then what is the answer you got here? 0.869 and nothing but 86.98%. There is possibility is there to get the number of calls more than 3 in 5 seconds of duration. And the second question is, aircraft arrive at an airport according to a Poisson process at a rate of 12 per hour. All aircraft are handled by one air traffic controller. If the controller takes a 2-minute break, what is the probability that he or she will miss one or more arriving aircraft? So, here the aircrafts arriving are defined by which random process? Poisson random process. How many are they coming for? 12 per hour. Nothing but what? 12 aircrafts are coming for 1 hour. In 1 hour, how many aircrafts are coming there? 12 aircrafts are coming. Therefore, this average rate here lambda equals to 12 per hour. And all these aircrafts are handled by only one air traffic controller. If the controller takes a 2 minutes of break, then what is the probability that he or she will miss one or more aircrafts? Therefore, what is the time duration here? T equals to 2 minutes. This is in hours, it is in minutes. So, convert this into minutes. And therefore, 12 by 60 per minute. Then what is lambda into t equals to 2 by, so 12, so 1 by 5 into 2. So, what is 1 by 5 into 2? Nothing but 2 by 5. Therefore, lambda into t equals to 0.4. Then what do you calculate? What is the probability that he or she will miss one or more aircrafts? Nothing but what? 1 minus p of, nothing but probability that he will miss the aircraft. So that you will get the probability that he will not miss the aircraft. Therefore, 1 minus lambda t per, nothing but 1 minus p of x of t equals to 0. So what is p of x of t is equals to k here? So it's nothing but e power minus lambda t into lambda t power k by k factorial. So you just substitute here in place of k equals 0. And what is the lambda t got here? 2 by 5. Then you get the probability that, what is the probability got here? 0.3297. Therefore, how much percentage of chance he or she will miss the break? She will miss the aircraft if it takes 2 minutes of break for getting the aircrafts. Then he is getting the, how many, what is the chance of getting here? 32.97% chance is there. He or she will miss one or more aircrafts if they take 2 minutes of tea break. Next question is, the customers arrive at a bank according to a Poisson random process with mean rate 5 per minute. Find the probability that during a 1 minute interval no customer arrives. It means the number of customers arriving at a bank are defined by what is a counting process. Therefore, they are defined by what type of random process? Poisson random process. And with the average rate, meaning nothing but here average only. With the average rate of meaning nothing but 5 per minute. Nothing but in 1 minute 5 customers are arriving to the bank. Therefore, what is lambda equals to 5. So, find the probability that during a 1 minute time interval. Therefore, what is the time interval t equals to here? 1 minute. Since both are same units, minute here and is also minute, then what is lambda into t equals to 5 into 1, nothing but what? 5. And what you have to find out here? You have to find the probability that during 1 minute interval, no customer arrives. Nothing but P of x of t equals to 0. No customer arrives. So P of x of t equals to 0. What is P of x of t equals to k? E power minus lambda t into lambda t power k by k factorial. What is k here? 0. So e power minus, what is lambda t value here? 5 into 5 power 0 by 0 factorial. Therefore, here, what is the probability here? E power minus 5. Or as 1 by e power 5. Next question is, the particles are emitted from a radioactive source at the rate of 50 per hour. Find the probability that exactly 10 particles are emitted during a 10-minute period. This is also same procedure. Lambda equals to 50 per hour. And the time duration t equals to 10 minutes. Therefore, convert this into hours or this convert into minutes. Then find out lambda into t. Then what do you have to calculate here? Find the probability that exactly 10 particles. Nothing but you have to calculate P of x of t is equals to k. What is k here? 10. So P of x of t is equals to 10. So lambda t, what is lambda t here? 25 by 3. Power k, what is k value here? 10. Into e power minus 25 by 3 by 10 factorial. Nothing but what? 0.1064. Next question is, x of t is a Weissen's stationary random process with the autocorrelation function 9 plus 2 into e power minus mod tau. Determine the covariance matrix for the random variables x of 0, x of 1, x of 2 and x of 3. So what they are given? They have given the autocorrelation function, and then what you have to calculate? You have to calculate the covariance matrix for the 3 random variables x of 0, x of 1, x of 2 and x of 3. So for this 4 random variables, you have to find out the covariance matrix. So first we will find out the mean of the random process. So what is the mean of the random process? Nothing but what? What is x bar square is equals to limit tau tends to infinity RHS of tau. So if you substitute tau equals 0, so tau equals infinity, then what can obtain here? Limit tau tends to infinity, nothing but here 9 plus e power minus 2 into infinity, nothing but 9. Therefore, what is the mean of the random process equals to plus or minus 3. Now, for how many random variables are given here? 4 random variables. Let us say x of t1, x of t2, x of t3 and x of t4. So, what is x of t1? So, what is t1 here? 0. What is t2 here? 1. And t3 equals to 2 and t4 is equals to the time 3 seconds. And you have to find out the what? The covariance matrix. What is the covariance matrix here? Covariance of x of ti comma tj, nothing but what? RHS of ti comma tj minus expectation of x of ti into expectation of x of tj. So what is the covariance of two random variables actually? U of xy minus u of x into u of y. In case of random variables, you have what? The random x of ti. So what is the random variable here? X of ti is one random variable and x of tj is a one random variable. And what is I here? I is equals to 0, 1, 2, 3 and j is also from 0, 1, 2, 3. Therefore, x of ti comma tj minus expectation of x of ti into x of tj. But they have given that is a Weissen's stationary. If it is a Weissen's stationary, then it is a function of only the time difference. Therefore, tj minus ti into expectation of x of ti into expectation of x of t. What is the random process here? The mean, nothing but is a, since it is a Weissen's stationary, expectation of x of 0 is equals to expectation of x of 1, because for all the values of t, it is a constant value. The mean is equals to plus or minus 3. Therefore, plus or minus 3 whole square. So, therefore, what is CA is equals to Rx of j minus I minus 9. So, what is Rx of here? Tau is equals to here 9 plus e power minus 2 into mod tau. So, 9 plus e power minus 2 into mod tau. Then, in place of tau, what is the time difference here? Tj minus ti, nothing but j minus I. So, for the first value, I equals to what? Here I and j. What is I value from? 0, 1, 2, 3. What is j value here? 0, 1, 2, 3. Then what is the first row here? 0, 0. J is 0, X is 0. Then what can happen? E power minus 2 into 0, nothing but e power 0. What is e power 0 value? 1 here. Next row. Here J equals to 1, I equals to 0. Then what can happen here? E power minus 2 into mod of 0 minus 1. Nothing but e power minus 2. Like that, you can calculate the covariance matrix. So today we have discussed about the problems on the Poisson random variables as well as the problems on the Gaussian random process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.